Okay, so this tutorial we will mainly just talk about non-homogeneous linear ODE with constant coefficient. So before we talked about homogeneous linear ODE with constant coefficient, and I talked about 3 different cases when you have a distinct real root, when you have repeated root, and when you have complex root. Before we start this, make sure you still remember what we did last time, because to solve a non-homogeneous linear ODE with constant coefficients, you need to do the homogeneous one first. So let's look at the problem. Suppose we want a particular solution to the nth order linear non-homogeneous ODE that looks like this. Okay, first of all, all my coefficients are constant, which means a and t, a 0t, they are constant, they are not functions of t. And then my g of t, which is this one, has to be a sum or a product of constant, polynomial, exponential, sines, or cosines. So if your g of t is one of those, then you can use our method, which is called undetermined coefficient. If it's not one of those, or sum or product of one of those, then this method does not work. You have to use this is undetermined coefficient. Oh, you need to use variational parameter. Okay, so let's look at what undetermined coefficient is. So the idea of undetermined coefficient is to take a guess. So you need to take a guess of what your yp will be, a linear combination of the functions in g of t. So you will guess your particular solution based on your g of t. If it's a constant, you guess it to be a constant. If it's a polynomial, you guess it to be a polynomial. If it's exponential, you guess it to be exponential. And if it's sine or cosine, you guess it to be sine or cosine. We will talk about how to take the guess later. But to solve, well, wait, where is it? Use it in ODE and then solve for the proper coefficient, which means you guessed it, you take the, well, y prime, the first derivative, second derivative, or whatever you need, plug it back into the ODE and solve for the proper coefficient. So to solve the nth order linear non-homogeneous with constant coefficient, one should typically attempt solve the associated homogeneous ODE and obtain a complementary solution. The associative homogeneous solution, which means you let your g of t equals to 0. Okay, so for example, here we need to solve this. In order to solve this, we let this be 0. Solve that homogeneous one first. That's going to give you a complementary solution. And then you guess a form of the yp based on your gt. We'll talk about how to guess this. And then you use this guess in ODE and solve the undetermined coefficient in yp. And the general solution is just yc, which is a complementary solution plus the particular solution. Okay? Oh, by the way, I call it complementary solution, but some places call it homogeneous solution. So it's the same thing, yc and yh. So some places might call it homogeneous solution. Not sure which one your professor is using, but yc, this is yc, and this is yh. They are the same thing. We actually meant the same thing. All right, now let's talk about how do we guess our particular solution. So let me draw something. So it depends on depends on your GT. So let's see, forms of GT. So based on this, we will have a guess. So guess for YP. I'll give you some example, but using those examples, you should be able to figure out the rest yourself. So for example, if your g of t is a constant, such as 3, okay, this is a constant, then your guess for your yp should also be a constant. So let's say the constant a. And you plug it in and decide what your a is after. The other thing is we can have a polynomial, for example, 2x plus 1. Then you see that this polynomial is a linear term, so your guess should be linear as well. So you should have ax plus b. Okay? Let's say you only have 2x instead of 2x plus 1. You still need to have plus b, okay? You still need to make it a complete linear term instead of just ax. So or 2x. Even if it's just 2x, you still need to use ax plus b. Let's use a quadratic term. So if we have something like 3x squared plus 5, then your guess for yp should be a quadratic term as well, and it has to be complete, so we would have ax squared plus bx plus c. Okay? It's not just ax plus c, you need to have the bx as well, although it's not here. Okay? And another example will be, for example, if you have x to the power 4 plus x, then here you would have ax to the power 4 plus bx to the power of 3 plus cx to the power of 2 plus dx, and then plus e, and so on. So this is polynomial. And then you might have exponential. So for exponential, for example, you have e to the 5x. Okay? Then your guess for your yp will be a times e to the 5x. Okay, so you just add a coefficient at the front. And lastly, if you have a sine or cosine, then you would have, for example, if you have sine 2x or you have cosine 2x, doesn't matter which one you have, then you would have a cosine 2x plus b sine 2x. So even if you just have one of them, you need to guess for both of them, okay? You need to guess a sum of both. So that's how we would guess. Any questions so far? Okay, I have a question for you. What if they give you a hyperbolic function? What would you do if they gave you a hyperbolic function? For example, like this. What would you do? Give up? What do you do when you have this? Okay, so first question you should ask you, if your g of t is this, does this fall in one of the category? If it does, which one it is? Well, I asked you, then it means it does fall into this. So think about what is the hyperbolic function. What is the definition? Never seen that before? You should have seen it in 232, I think. It's 232. I think it's a prereq. Didn't seen it, never seen it. Okay. Exponential. Yes, exponential. Okay. So why? Because this equals to, if you've never seen it before, here I'll tell you what it is. I'll write it here. Okay. So let me use another color since you've never seen it before, and they can test you on this. It is possible because you're supposed to know this. This equals to e to the x plus e to the negative x over 2. Okay, so this is actually exponential. What about the other one? Anyone remember? What is this equal to? Yes, exactly. E to the x minus e to the negative x over 2. Okay? So if they give you something like this, you should know that, well, it does fall into one of the category, which is exponential. Okay? So you can guess your solution based on this, based on exponential. So if you want to guess this, that's going to be something like a e to the x plus b e to the negative x. Right? Anyway, that's one thing I want to mention. The other thing I want to mention is this. Sometimes your complementary solution might contain a term that looks like your particular solution. Then in that case, we need to do something about it. Where do I write it? Let me think. I need more space. I wrote it too big already here. So let me write it here. Warning. Okay. In general, your complementary solution or homogeneous solution may contain terms that are not linearly independent with terms in the guess of yp, and this must be avoided, and I'll tell you how to avoid this. So if you see something like this, you need to multiply by x, exactly. But this is a common mistake, which we will see later. A lot of people know that they need to multiply by x, but they still make mistakes, and I'll tell you why. So let's write it down first. So if you see that, you need to adjusting the method. So in the situation above, the duplicated terms in yp must be multiplied by t to the power of s, where s is the smallest integer that removes the duplication. Okay, so sometimes you just need to multiply by, well, let's say t or x, and that removes the duplication, but sometimes you need to do more. For example, let's do an example. Let's say example, so let's write it here. Example, let's say your yc equals to c1 e to the t plus c2 t. and your g of t equals to 3t squared. Okay, so now what is gonna be my guess? Guess for yp. Anyone know? So my yp should equals to what? Ax squared plus bx plus c. No. Yeah, that's why I said it's easy to make a mistake here. Nope. Why? Because your bx and your, oh, it's t here. Your bt and c2t are linearly dependent. Ax cubed plus bx squared plus cx, still not correct. Because your cx and my c2t, they are linearly dependent. So what is my answer? Yes. So my guess should be a t to the power of 4 plus bt to the power of 3 plus ct squared. Okay? That is why I said a lot of you know that you need to do this, but you still get it wrong because you need to check. Why is that our guess? Okay, so why? Originally we should have this a t, where is it? Yeah, so this is the gt. Originally you should have a quadratic term, so at squared plus bt plus c, but this and this, okay, they are linearly dependent. That means we need to multiply by t. So multiply by t, you'll get this at cubed plus bt squared plus ct. But now this term and this term, they are linearly dependent. So you need to multiply by another t. So eventually you should get this. Does that make sense? Okay, so be careful. I know you all know this, but you all know this, but you still might make mistakes. It's really easy to make mistakes. Okay, let's look at example 1. So I'll give you 2 minutes to think about it and tell me, type in the chat your answer. Okay. Gonna get some water. Let's see, 2 is correct. Yeah, 2 makes sense, correct. Actually, should be okay since we will get. Yep, the answer is 2. 2 is the correct answer. Okay, let's see why. Well, first of all, you have a linear term, right? This is linear. which means your guess will be ax plus b. And now you have a periodic trig term. So cosine x, this will give you ax, no, not ax, a cosine x plus b sine x. Now combine those two together. Okay, you'll see that, well, I need a linear term multiplied by cosine plus a linear term multiplied by sine x. So eventually this should give you ax plus b cosine x plus cx plus d sine x. So that's why the answer is 2. Any question? If no question, let's do example 2. Okay, I'll leave it like this in case anyone needs to copy it down. So let's do example 2 and let me know once you're done. The derivative is so annoying. Whoa, this is not annoying. Once you reach the later part of the course, you'll see what's annoying. Not trying to scare you. Actually, it gets really annoying later because you have a system of equation. So computation is like multiple times of what you're doing right now. So each of the question you might spend pages on that. Be mentally prepared, I would say. We'll be there very soon. You need to do before we reach there, make sure you review 223. Yeah, 223. Make sure you know how to find eigenvalues and eigenvector. That's really important for later part of the course. So if you don't remember, you should review now because we'll reach there very, very soon. What else do you need to know? I think that's it. Matrix exponential, which I think they'll teach you, so we don't need to review. I don't think you did that I don't think you did that in 223. But eigenvalue and eigenvectors Make sure you know how to find those. Are you guys down for example 2? Okay, let me just start writing because it's gonna take a while to write. Cosine 2x minus 4b sine 2x. I'm tired of writing already. Should I type the question up next time? Oh, I mean solution up next time? Or write it beforehand so we can cover more questions? What do you guys think? Or do you prefer me writing down? General solution is complementary solution plus a particular solution. So y equals to c1 cosine 2x plus c2 sine 2x minus 3 over 4x cosine 2x. Okay, now I've finish writing, let's talk about this. So as I mentioned before, basically you need to first solve the homogeneous solution, homogeneous equation, which means you let this equals to 0, so you find your characteristic equation, which equals to m squared plus 4 equals to 0. This you will get m equals to plus minus 2i, so your complementary solution looks like this. Now, if you look at your gx, you'll see that based on this, your guess will be a sine 2x plus b cosine 2x, but those two, they are linearly dependent with your complementary solution. So in order to remove that, we need to multiply by x. So your yp will be ax sine 2x plus bx cosine 2x. Now, since you need y prime prime here, you need to take the second derivative of this. So after you take second derivative, you'll get this. Now you plug it back into your ODE. So basically plug it back in and make both sides equal. You'll get 2a cosine 2x minus 4b sine 2x, which equals to 3 sine 2x. Now you can solve for your a and b. So you get a equals to 0, b equals to negative 3 over 4, and your particular solution is this. And you just need to add the complementary solution and particular solution together. Okay? Oh, any question for this? Question? Well, I feel like I don't have enough time to do all my questions. Can we move on? Yes, no? I think I can move on, right? No questions. Okay, let's see. I have 3 more questions, but I think I only have time to do one of them. Which one do you want to do? 3, 4, 5, pick one. And let's do one of them. Sure. Do the last one? Okay, let's move on to the last one then. So, it's 50 now. I'll give you some time to think about it. What you need to think is, first you find your complementary solution and then try to guess your particular solution. Okay? So the other are just computation, so let's not waste too much time on that. Try to do the first 2 steps. Yeah, I want you to guess the particular solution. So what's gonna be your guess? Don't need to solve the whole thing because we don't have time to solve the whole thing. I will solve the whole thing, but you don't have time to solve it. ax e to the 2x plus bx e to the negative 2x. I would say, honestly, for me, you really want to have two things like this. I will do them separately, but I think your way works as well. So I would do them separately. I would do y1 and y2, and so that I only need to multiply by x once. Don't know if you understand what I'm saying. I'll do it like this. So this m squared minus m minus 2 equals to 0. So my m equals to, so this is, slapping me using your tail. What's my m again? 2 and minus 1, yeah. M2 minus 1. So my yc equals to c1 e to the 2t plus c2 e to the negative t. Okay, now what I'm gonna do is I'm gonna guess y1. So I'm gonna guess y1 and oh, actually I'll write this as exponential first. So this equals to 1 over 2 e to the 2t plus e to the negative 2t. So what I'm gonna do is I'm gonna guess those two separately. So I'm gonna take y1. So I'm gonna guess y1 equals to at e to the 2t. And then I use y1, solve it, and then I'll guess y2. So guess y2, I mean yp1 and yp2. Because it's addition, so I can do that. Yp2 equals to b e to the negative 2t. Oh, negative t. Okay, I can do that because it's addition. So in this case, let's solve this. So yp1 prime equals to a plus 2at e to the 2t, and yp1 prime prime equals to 4a plus 4at e to the 2t. So plug it back into ODE. You will have, y prime prime, so 4a plus 4at minus a minus 2at minus 2at e to the 2t equals to, this is 3a e to the 2t, which would equals to 1 over 2 e to the 2t. So now I can solve for a. So a is gonna be, wait, 1 over, wait, did I miss anything? A equals to 1 over 6. So my yp1 equals to 1 over 6 t e to t. And then I solve for yp. yp2 I meant. Let's do it here. yp2. So yp2 prime equals to negative 2b e to the negative 2t, and yp2 prime prime equals to 4b e to the negative 2t. Hopefully I did calculation correctly. Then you plug it back in. So back into ODE, you get 4b plus 2a minus 2a e to the negative 2t equals to 1 over 2 e to the minus 2t. So 4a equals to 1 over 2, a equals to 1 over 8. So your yp2, wait, why did I use a here? I meant b. Keep using a. b, 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 b. So 1 over 8 e to the negative t. So your general solution is going to be complementary solution. So this one plus yp1, which is 1 over 6 t e to the 2t, and the yp2, so 1 over 8 e to the negative t. Any question? The 2 disappeared again. Which 2? Negative 2t. Oh. Did I? Negative 2t. Where before the t?
In yp2.
Say it again?
In yp2 you have is equal to 1 over 8 e to the negative t, but I think it should be e to the negative 2t, no?
1 over 2 e to the
1 over 8 e to the negative. Shouldn't that be 2t, not just t? Yeah, so when you bring that down, when you solve for b, plugging b back into the equation, shouldn't that be
Isn't
negative 2t?
1 over... No, here. It's b e to the negative t.
Okay.
It's not from here. It's from here.
Okay.
Because you plug your here.
I see. Okay.
It's negative 2t. Isn't it negative t? Oh, it's negative 2t. My bad. Yeah, you're right. Okay. There. Any other question? This is right? Let me check again. Here it's negative t, yeah. And 2t and negative 2t. I used 2t and negative 2t. And negative 2t. So it should be 2t, t e 2t, and t negative 2t and negative t. Yeah, now it's right. Well, you should get it before. I don't know, to be honest. I'm trying to finish marking the question 2, but even if I finished, I'm not sure when the other TA is gonna finish, so I don't know. Yeah, I'm trying to finish it as soon as possible, but I'm not sure. That question is taking me really long. Yeah. Hopefully soon. I plan to grade tonight, so hopefully soon. But another TA hasn't started grading yet, so I'm not sure. No problem. Good luck on your homework. And if you have a test next week, good luck on your test. Have a great week. You too. Stop recording.